Hey, welcome back to Math with Patrick. Today is January 13th, and we're solving the 13th problem from this Daily Epsilon calendar. Let's try it out. All right, find the largest solution of this equation. Got it? Well, let's see. So the solution is going to be some number that we stick in for y. And it looks like we're trying to find the largest. So maybe there's a whole bunch of different numbers that could work that satisfy this equation. And we just need to find the biggest. So I see that I have some base to some power equals 1. And as far as the real numbers go, basically I could have -1 to some power equals 1. That's possible. This would just have to be even. Or I could have 1 to some power equals 1. And this could be pretty much anything. So that's what I'll try first. Maybe I could get a -1 or a 1 out of the base, and I'll see what happens to the exponent. Well, in the case that the base is -1, I know that 25 minus 2y has to be -1. And let's see, I'll add the 2y and I'll add the 1. So I'll get 25 plus 1 equals 2y. And the 26 divided by 2, this tells me that 13 is a possible value for y. And over on this side, maybe it's 25 minus 2y is equal to +1. I'll do something similar. I'll add the 2y, but then I'll subtract this 1. So I'll get 25 minus 1 equals 2y. So over on this side, I have a 24. And 24 divided by 2 is 12. So 12 seems like another solution for y. Well, I got two choices so far, and I haven't considered this exponent part yet, so let me double check. If y is 13, let me plug it in. I'll get 25 minus 2 times 13 to the power of 13 squared minus 25. If y were 12, then I'd get 25 minus 2 times 12 to the power of 12 squared minus 25. Let's do a little arithmetic. On the left side, I have 25 minus 26, so that's a -1 as the base. Kind of already knew that because that's how I found the 13 anyway. And then I know that 13 squared is 169 minus 25. I'll do the right hand over here as well. Here's the base of 1. That's 25 minus 24. And 12 squared is 144 minus 25. So on this right side, I mean, clearly, like I said earlier, 1 to any exponent is just going to be 1. It's like I have 1 multiplied to itself a bajillion times. Okay, that was an exaggeration. 144 minus 25 is 119. There we go. That's a 1. And then on the left side here, 169 minus 25 is going to be 144. Oh, it's kind of neat that it's kind of like the 144 over here. But the important part is that it's even. And so -1 to an even power is going to be 1. So that's a 1 right here. And between the two potential solutions that I have, 12 and 13, 13 is of course the bigger one. But how do I know that there isn't another value of y that's bigger than 13 that will make this equation true? Like, sure, of the two that I found, 13 is the biggest, but what if there's another one? Or maybe it's another two solutions. I know that if I have some base to the power of 0, that's always going to be 1, well, as long as the base itself isn't 0. 0 to the power of 0 is undefined. It doesn't have an actual value. But anything else to the power of 0 is 1. So my exponent has to be 0, or in other words, y squared minus 25 equals 0 could help me find other potential values for y that will make this equation true. This is a quadratic equation. I'll solve it with square roots. How about? So I'll add the 25 to the other side. I'll hit both sides with a square root. And if you're using the square root as an operator, as in like you're the one putting the square root there, you always need this plus or minus sign. That's just because if you have a negative number squared, it's still positive. And a positive number squared is still positive. So this y value could be positive or negative, and you just don't know. So you got to do both. And then finally, the square root of 25 is just 5. So I found 2 more solutions that should work for this equation. I guess I should double check that they do, but I mean, I think they will. That'll be, so 25 minus 2y. I'll do the positive 5 version first. And then the power is y squared, so 5 minus 25. The base here, 25 minus 10 is 15. But then, like I thought earlier about like the exponent needing to be 0, that's how I found this 5 anyways. 5 squared is 25. 25 minus 25 is 0. So this does produce a 1. And negative 5 does as well. So I'll plug in the negative 5 here. Minus 2 times negative 5 to the power of negative 5 squared minus 25. Again, it doesn't really matter what the base is. I mean, here it's going to be 35 because I'm adding a 10 right here. Exponent, still 0, and so I still get a 1. So I believe these are all my potential values for y. Either my base was 1, or my exponent was 0. But between 13, 12, and positive or negative 5, this one right here is the winner. This is the largest. So there it is. I found that 13 is the solution, well, one of the solutions, but it is the largest of the solutions. And that's it for today. Thanks for coming along. It was great seeing you again, and I'm happy to solve problems with you. I'll see you in the next video. Bye.